Hello, welcome to the Elixir Roundtable with Dockyard. I'm Nathan Long. I'm a senior software engineer at Dockyard.
Hi, I'm Gustavo, and I'm a senior software engineer here at Dockyard too.
And today we have our very first guest, which we're very excited about. Ben Wilson is joining us on this show. Ben is the author of Craft GraphQL APIs at Elixir with Absinthe and co-author of the Absinthe package, which was released back in 2015, and he's been doing GraphQL at least since then. So he did an excellent interview on the Thinking Elixir podcast, which you ought to go check out if you haven't heard it, which just really helped me understand why I would want to use GraphQL in a project. And I loved that interview. I listened to it several times, and I just thought he was very insightful. And I wanted to have him on the show, especially because Gustavo and I are actually working on a client project now where we're building a GraphQL API. And so as we've gotten into that and sort of gotten a little more context around how to do this, all these questions come up and more interesting things. So this is our chance to get to talk to Ben and get some more insight on how you do these things and recommended practices and just anything cool that he wants to share also about Absinthe and GraphQL. So very excited to have you on the show, Ben. Is there anything else you want to say as we get started?
Well, first, thanks for the kind words. Thanks for having me on here. It's nice to be talking with people about Elixir. I don't know about you, but the last 18 months have involved a lot less being with people and talking about Elixir than normally I'd like. It's it's great to be doing this, both because of COVID and because of sort of what's been going on with CargoSense, where I work. We've been pretty busy, but as we're going into next year, looking to sort of hopefully actually get to some conferences and chat with folks more. And so this is a great way to get back into that. So thanks for having me.
Cool. Yeah, glad to do it, and I definitely understand about getting to talk with people. It doesn't happen as easily anymore.
Yeah, no, not so much.
So before we get into the nitty gritty of all the questions that I have, I wanted to just call out a couple of the things that I thought was really cool that you pointed out. I'm going to just tell you some of your own things back to you if that's okay. But like some things that you said that I thought were really insightful and cool. That was like, I want to do GraphQL now. Because I remember when I first heard about it, I was kind of like, oh, this newfangled thing. I don't know, Facebook something. But some things you pointed out that I thought were really, really cool. One is just the concept that users can ask for what they want and get just exactly what they want, no more, no less. So for example, if you haven't used GraphQL, anybody who's listening, somebody, instead of saying like, give me this order and then making follow-up requests for the items, you can say like, I want the order with its date and its total and all of its items and the prices on each of the items and the descriptions on each of the items, but I don't care about the product numbers and I don't care about the shipping date and whatever. I just want this exact shape of information, please. And they can get exactly that. Which is good for payload sizes and good for not having to make multiple requests, which is especially good in high latency environments. So it's just super nice. And then you also pointed out that you can tell what people are asking for. So you can tell what fields they care about. And then another one I think that was a big...
Well, if you don't mind, if I can hop in on that one, just
totally,
for a moment. One of the things that is a sort of logical consequence, I guess, of that is it changes a little bit what constitutes a breaking or impactful change to an API. Because when you're working with an API structure where end clients do not specify the data that they are asking for, you have to be very mindful about adding additional fields, because suddenly you're going to be sending them data that they did not have before. And even if you're using JSON, and you're using a real parser where it's sort of it's not going to use static byte offsets or something, or like where protobuf or other things where there's a very rigid format. Even still, having that extra data, especially if it's a large change, will impact mobile clients. It can impact logging. Maybe they are serializing that payload to a column somewhere for to track events and whatnot, and suddenly you've doubled its size, and this has an impact. And so you can, because you are not sending people data that they didn't ask for, you can, generally speaking, add available attributes to GraphQL objects anytime you please, and they'll be available to folks who, new clients that are getting written, they're going to use that, or edited, they're going to use that. But as long as you are not removing fields, it's really not a breaking change. And we've been able to retain enormous backwards compatibility with, in these 6 years since we wrote Absinthe, with old customers of ours, old some really purpose-built tools we wrote for certain customers that we kept thinking we might need to update to keep up with APIs. We haven't. It still works, and the GraphQL has really helped with that because of these properties.
Yeah, that's great. You don't want, like, if one client needs a new field and let's say they're like point of sale on broadband, and you start setting this new field, but then everybody that's on a mobile phone and like rural areas is like, why is this slower now? So yeah, that's
exactly
really
right.
great that you don't have that. Another thing you pointed out that I thought was really cool, also feel free to comment on this, but you said like REST is so tied to HTTP verbs. It's all about those verbs. Whereas, what if you're doing WebSockets? What if you want to send requests over a queue, or like message bus kind of style, or basically anything that isn't REST? And that also seemed really like an interesting point, because we are all trying to do WebSockets these days.
Yeah, and it provides more flexibility in what you consider and sort of use your API for. So, for example, we have had in the intervening years since I last talked about this, we've added a lot of customers. Those customers have needed us to like integrate data with them in a lot of ways, and so sometimes they want a REST-like interface, sometimes they don't, and we're pushing things over Cloud Pub Sub or SQS or whatever. In all of those cases, we were able to write relatively simple interface services that could make GraphQL requests, that sort of could carry out the operations that need to happen or query certain data based on certain triggers or whatever, and then push that out either as an HTTP response. So like if it's imitating REST, they're going to post to some endpoint with a payload. Our little integrator service can just reformat those inputs, run a GraphQL query, get data back that matches the sort of expectations we want to send to that client. Off it goes. If it's over a message bus, it's the same thing. We get a message in, make some GraphQL queries, push responses back out. It has offered us immense flexibility without having to. You can, of course, like when you're a really small company, you might just be doing this in one app anyway. You get a message bus in, you hit your Ecto, you hit your Phoenix context functions. So I'm not pretending here that GraphQL has invented the idea of a reusable interface, but by operating at this slightly higher layer, as the company has grown, as we've grown our team, as we've grown our customer engagements, it's given us the ability to make enormous structural refactorings to our Elixir apps underneath, while continuing to have a very cohesive but flexible API on top. It's not one of those things where, okay, well, we got to mungit the underlying data so that these sort of legacy REST APIs can do their thing or whatever. We can continue to add stuff, evolve things, and it's worked in all these disparate communication contexts. A good, interesting example of that, speaking of what people are up to with WebSockets these days, when we were writing the Absinthe book, the new thing was Phoenix Context, and of course the new thing now is Live View. And so because we had this core platform application that had a GraphQL API that we'd built mobile apps against, and at points JavaScript UIs against and whatnot, we wanted to start using Live View. We had a lot of Elixir developers, and it seemed like a good way to sort of help us all be effective across the full stack of software. Which is a whole conversation there. But in any case, we started running live view. But unlike probably 99.9% of all live view applications out there right now, instead of having live view hit the database, we wrote a live view service that makes GraphQL requests. Again, they're actually totally separate services. This is good for us operationally. But what was interesting about that is it was super natural. You have this page, it loads, you might make a couple of GraphQL queries to fetch the data needed, then you're going to set up some subscriptions, you get messages when stuff updates, you can update your live view. It was astonishingly simple to wire in to make these pages live. And it's there that immediately we felt one of the benefits of that higher layer API abstraction over something like just doing it in your Phoenix app with Phoenix context. So for example, and I have not looked at the some of the Phoenix live view demo apps in a few months. So if it's changed a little bit, I apologize if my rendering of it is a little bit imprecise. But a lot of it boils down when there's a sort of user live example, and you're going to have kind of a CRUD page for managing users or something. And when you edit a user, you want anybody who's looking at that user show page for the data to update. Great, classic use case. Uses Phoenix PubSub. Phoenix PubSub is great. But the problem is what data should you be broadcasting when a user changes? So the way it works roughly is that, and there's some parameterization of this stuff, but when you hit the Phoenix context function to edit a user, it does the usual database stuff, and then it calls Phoenix PubSub publish, user updated, sort of a tuple user updated, and then the user result. And then in the live views, when the page mounts, you're going, fetch the user and also pubsub.subscribe user edited or something like that. The problem with this is, what do you want to do what do you do to load extra data how do you want to say, hey, when the user updates, I also need their post count, or I also need these other things. And you can just, I guess, call a bunch of extra functions, but you have a lot of like supplementary data lookup to do. And suddenly that's, if you have, 1,000 different processes that are all doing this, they're all going to be suddenly having to do all this follow-on data lookup on their own. And there's not an API, there's not a standardized way to do that really. And so in our app, when we took GraphQL has a thing called fragments, which is sort of a way to say, here's a named collection of fields that I would like to have. We could just take a lot of the fragment we used to load the user when we looked at the page, shove that into a bunch of subscriptions that we were going to rent. And then if that changed, we just got the same data again. And it meant that we weren't having to sort of invent a new standard, either at sort of the WebSocket layer, if you're doing this in single page JavaScript land, or even at the sort of Elixir context function layer to say, how do I follow up on this event, this thing that's happened in our system?
So in theory, you could have two different live views, maybe like an index view and a show view, and then a bunch of individual users that are looking at those. And when the single user gets updated, probably shouldn't have used users for both of those, but when the single user record gets updated, all of the people that are looking at the index page, their live views are getting the benefit of one database query sent out over subscription to all of them. And then for the show page, like one query that's sent out to all of them over that subscription. Or maybe they're using the same subscription, but
there are two advantages. I would say one of them, to address the one you're bringing up first, was sort of a performance and data architecture question, and then there's sort of a developer experience thing. So on the data architecture thing, yeah, we're Absinthe. Each of your 1,000, let's call them clients, so that we can distinguish them from user records. You have 1,000 clients. Each of them is going to get their own live view PID. And each of those will submit a GraphQL subscription. And Absinthe gives you a way of saying, hey, I am or am not able to batch some of these subscription records together. You have to be very careful about this. If the data you are looking at, for example, should be evaluated against authorization rules that are per user, then you have to be careful about whether or not you're going to consider that sort of a single logical subscription or not. but it does sit in the middle. It gives you an opportunity to tune that. If you have 1,000 users and they're all sort of unauthenticated, then you can tell Absinthe, these guys are not, use basically an unauthenticated context to evaluate each of these things. That'll result in basically one subscription. And then, yeah, it will do one database lookup for all your supplementary data, turn that into JSON, and then do a fast track Phoenix publish out. So you can do some neat optimization stuff in those cases. In the case where you do need to, it's 1,000 individual clients and you need to evaluate their parameters against each of them, then you are going to do a bunch of individual GraphQL evaluations. But what you're still getting there is a lot on the developer experience side, where the code that you use for, you're not having to sort of invent within your company a spec for saying, we want some extra data on the list page, but like a little bit more data on the show page. What's going to be our spec for pulling this stuff up? And you've got that in your GraphQL API. And then any of the actual optimizations you put into making your GraphQL API work a given GraphQL request, evaluate efficiently, data loader, internal caching, whatever, you get that for free basically when evaluating subscriptions, and not, oh, well, we optimized how the REST API, its controller actions fetch this data, but we didn't optimize it over here in this other thing, and now we got to do the same thing. Or you're constantly having to juggle what makes sense for the controller access pattern versus a sort of live process access pattern. You don't have to worry about those things.
Okay. We've gotten into subscriptions, and I think maybe I'll go ahead and ask some questions on this. But I will say subscriptions is probably the piece that I know the least about at this point, because in our API that we've been working on, which is like not quite done yet, but we've only just gotten to start touching subscriptions, and one of my colleagues at the client is actually doing that piece at the moment. But one of the things that he ran into was he saw a need to sort of limit the amount of associations that people could query in that subscription. He said he ran into pretty high memory usage, if I'm recalling correctly, when people were allowed to the subscription was allowed to just request a bunch of associated things. So maybe, for example, if it's a post, I'm not going to give our the actual business domain, but if it's a post, you don't want to let them get post, author, posts, comments, so he created this restricted version of a post. It's like, with subscriptions, you get this data for a post. Does that, and basically he said it works. So he didn't need to do that when he had one subscription, but when he had multiple subscriptions, was when it started to get hairy. I don't know if that's sort of inherent in it, or if there's something that we're missing.
Yeah.
Does that sound like a familiar problem?
Yeah. So two parts to this. The first is if we've done a couple of things to try to improve memory consumption for Absinthe and subscriptions. And to talk about that, it's important to distinguish between the two activities that Absinthe has to do and how they affect your memory. So the first activity that Absinthe has to do with the sort of built-in subscription implementation is that it has to store all the different subscriptions that have been sent to it. So if you have some clients and they are each going to subscribe to make 5 subscriptions on a page or whatever, though Absinthe has to hold on to those in memory so that whenever it can know what to evaluate and push out to the end client whenever it is triggered. So this is stored inside of a Phoenix or an Elixir registry. And early on, Absinthe did some stuff to try to, that's the first thing, that's the first activity. And then the second activity is, okay, it has been triggered. Let's fetch all of the subscriptions that are relevant for what has been triggered, evaluate them, and then send results to clients. So those are the two activities. Absinthe made some early choices I said I made some early choices to optimize for the second activity in a way that had more of a memory impact than I realized on storage. So early on, and really actually until 1.6 something, what we stored was the parsed. When you submit a GraphQL query string, Absinthe parses this and then sort of turns it into what we call a blueprint, which is sort of a deeply nested Elixir struct that holds all the type information and lets us validate the document and so on. So we stored the blueprints themselves in the registry because we were like, therefore, we don't have to reparse it whenever we run it. And this is cool in theory, and in practice, the parser is really fast and the blueprint tree is really big. And taking it in registry is backed by ets, and so taking it in and out of ets involves a lot of copying. And so this was a poor choice. And so we refactored that to just, so what we did is we still marked a number of phases that we could basically skip. So like when you submit the GraphQL query string, we parse it, validate it, prep it for execution, and then execute it. The validate it steps, we don't need to do again. It was validated when it was stuck in the registry. It wouldn't be there if it wasn't valid. Therefore, when it is triggered, we pull it out, do the parsing step, skip a lot of the validation steps, then do the prep for execution and execute. So we got half the savings I was going for anyway. And the memory usage dropped precipitously. The second thing on that note is that if you are not switched over to using the persistent term schema backend, which came out in, I think, 1.6, it was experimental in 1.5 something, and I think came out in 1.6, I highly recommend it. So this gets a little bit into the more details of how Absinthe works, but the high level thing is that when every process in Elixir has its own heap, and this is one of the really great things about Elixir, Erlang, really, we just got that for free from the Erlang folks, is that each process, if you have a process handling web request 1, a process handling web request 2, web request 2 is doing something very memory intensive. If it needs to do a garbage collection, this does not stop, freeze, or otherwise mess with other lighter weight processes that are handling other requests. This is really great. To make that work, though, you have to know that each process's memory isn't intermixed with one another. Otherwise, you'd have to be chasing pointers across processes, couldn't be independent anymore. So what that means is it poses a bit of a challenge for frameworks like Absinthe that need to hold on to a really relatively large hunk of information that describes, say, for example, a schema. If a HTTP request comes in, or it's a WebSocket, whatever, you have a process trying to execute a GraphQL document, Absinthe needs to know the schema in order to evaluate it. And the schema is pretty big. And so the question that we had to sort of answer is, where do we put that schema and how do we manage access to it so that it's not creating this like heavyweight burden on process memory all the time? So in older versions of OTP, Erlang and OTP, the sort of classic answer to that was you try to, at compile time, build a bunch of literals that basically in a module somewhere, and that's what ends up in the literal pool. This is what that really means is like if you have a big string like in your code, in a file of code, and that code is loaded, that is in one spot in memory, and all the processes can just hold a pointer to it because it's immutable. It can't ever possibly change. There's no need to be copying that all the time in different processes. So this is what's called the literal pool. And so Absinthe schemas were built in such a way that they tried to expand all the DSL into a literal that could be in that pool. This was hideously difficult to do and was not always super successful. It was relatively easy to do things in your schema in terms of how you ran your middleware callbacks, in terms of how you ran other stuff that would limit. It wasn't like it totally ruined it, but it limited how much could be a literal. And that meant that this meant two things. One, when you wanted to fetch a type out of the schema, there'd be a small amount of like actual computational overhead to go compute whatever value it was. But much worse from the perspective of memory, it had to like make a copy of a bunch of that schema stuff into the local process heap so that it could update keys and stuff. In OTP 23.2, I think, they created the persistent term module, which is a beautiful, beautiful thing. Basically, it's like a big key value structure for the literal pool. You can just, usually at the beginning of your app is where this is recommended. You can say persistent term dot put, and you put a key, and you put any Elixir term in the value argument that you want, and it shoves it into the literal pool, and then it can be referenced for kind of free by other processes. There's a trade-off here in that if you edit that key, it has to pause every single it tracks which processes basically have access to that, and if you want to edit it, it has to pause all of them and do a big garbage collection. So it's not really built for things that change with any frequency at all, but it is perfect for things like GraphQL schemas, because when your application boots as part of the supervision tree, you can compute your fully realized schema, shove it in persistent term, and then access it very cheaply within all your different processes. So this has a very significant memory improvement that I highly recommend. If you are not using, you should use. And last but not least, you really should be on OTP 24, because the JIT has, like, in basic testing, it improves the performance of the introspection query by like 30 or 40%. It's really quite fantastic. So that's sort of like Absinthe general. The one last comment I will make is that a common mistake people make when doing subscriptions is they store too much data in their GraphQL context. And this goes back to those two activities that Absinthe has to do. So Absinthe needs to store everything it needs to run a query in memory, so that when it's, or a subscription, so that when it's triggered, it can execute and run it. Well, Absinthe needs basically three things in order to execute a document. It needs the actual query string, it needs any variables that it's going to be applying to that, and it needs the context. And so what we've seen is people will like put in their context the current user, all of its permissions for all things it can touch, and all of its, I don't know, like, and a bunch of stuff. They like preload, and it's normally, it kind of makes sense, because if it's like a normal HTTP query, you're going to just use that in the query and then forget about it when the request ends. But people will put like megs of data in their GraphQL context and then have that, and then do 1,000. If you have a megabyte in your GraphQL context and then you do 1,000 of them, that is a gigabyte of memory. So basically, you have to be very attentive to that. And the way you can kind of cheat here. So in your actual context within like your socket, you can keep it very minimal and then use middleware to kind of reinflate it at execution time. So middleware is not run when the GraphQL query is submitted, it's run when it's executed. It's part of the resolution process. So you can apply middleware to the top level subscription fields that takes your relatively like anemic context, fetches some extra stuff out of the database, sets the context to something different, and then as it executes all the fields underneath, that will be available to them. So definitely be attentive to that. The very last thing I'll say is like a forward-thinking thing. Sorry, it's very easy to get me. Please feel free to interrupt me at any time. I will.
No, this is great.
About this. Okay.
That's great.
Thinking forward,
It's great.
there are a couple of things about, and actually Jose and I were talking about this because there's some stuff about Absinthe basically could be doing more to try to ref count certain values that are essentially duplicated. So if you have literally the same socket, and we've run into this. We have Carcassonne does logistics, shipments, and stuff. And so when you go to our list of shipments page, on each shipment, we're listening for like 5 events, and there's like 50 shipments. And so a client could submit 250 GraphQL subscriptions, which is a lot. And and it turns out to not make terribly much difference whether it's 250 subscriptions on different topics or one, or with each one topic, or one subscription that hits 250 topics. It ends up being a little bit of the same thing. Either way, that context right now on that WebSocket connection is duplicated 250 times. Now, there's a certain amount of duplication that is necessary. If I have my browser and I have 4 tabs open, it's deeply difficult to deduplicate between those individual tabs because they are 4 distinct Elixir processes. And if you try to, anywhere you try to introduce deduplication between them is also a coupling between them. And so it means like you want to handle things concurrently. You don't want to have to like pause one PID. So to try to, they can all act concurrently. And so you can't assume that you have like a snapshot view of like 3 different ETS tables. So sorry, to step at a slightly higher level, the optimization we'd like to do is if for a single process that is submitting many GraphQL queries, we can have that process do a little bit of bookkeeping about whether it has already submitted its context to Absinthe or not. And if it has already submitted it, then it can actually just basically send us a pointer. We can register these contexts under a unique integer. And then if we are trying to send it again, instead just send Absinthe that unique integer over and over. And so then you really have that context just once in memory. And then Absinthe, when it fetches a particular triple of query variables context, if it gets that little, if it gets like an integer, a tagged integer instead of an actual context, it can go, oh, let me just go fetch that. And then it's got it. So you pay like 1 extra ETS lookup, but for like 50x memory improvement. Like it's really, really, really big. We got working on it, and then I ran out of time. And that there's a subplot here that I'll get to in and around like things I've learned around managing large open source projects that I'll come back to. But that's sort of where we stand on subscriptions and memory usage and some common pitfalls and how Absinthe works.
Having an infant doesn't make it at all harder to do things like personal hygiene or like basically anything gets harder with an infant.
I wrote more open source software during my paternity leave than I have since, because I was awake at like my daughter for the first like month of her life wouldn't sleep not in somebody's arms, like on their lap or something, and so because she was a little early anyway. So what that meant is I'd be awake at like 5 in the morning, and I'm like trying to stay awake. I'm like, all right, just gonna hack on this Absinthe problem. And so I wrote plenty of code then, and now I'm like trying to juggle a job and all this stuff, and it is hard to find time for open source, that's for sure.
Gotcha. Well, jumping out of the topic of subscriptions, I wanted to ask you some stuff about complexity analysis, if that's okay.
Yeah.
Because this is where I feel like GraphQL is a little bit of a double-edged sword. Like, the cool thing is clients can ask for whatever they want, but the bad thing is clients can ask for whatever they want, right? And so like if they ask for all your data and you give it to them, you're probably going to have a bad time. Complexity analysis is how we basically say you're asking for too much in this one query. You need to tone it down. And in the examples that I see in the docs, there'll be, well, let me back up. The way I understand this, when we assign a complexity number, it's basically like saying how many fields do I think I'm going to have to give you. It maybe doesn't have to be understood quite that way, but like if I ask for 1 user and 5 fields on it, then maybe that's a complexity of 5. But if I ask for a user and their trying to think of an example, there are 3 posts, each with a title, that that adds 3, right? And so like if you're asking for a page of 10 results with 5 fields each, that's 50, right? So something along those lines is kind of the calculation we're doing. So I often see in things like if you're asking for the first 5 records, we're going to multiply that by what we think is coming on one record. The thing that gets a little bit unclear for me is when you don't know how many child associations there are going to be. So if somebody's asking for a page of authors, okay, 10 authors on this page, great. 1 name per author, great, I know what that is. All of the posts of that author with their titles. Well, how much data I'm going to send you depends a lot on how many posts we have per author. And some authors will have 3 posts and some authors might have 1,000 posts. And so the best answer that I've come up with on that right now is to either guess high when doing the complexity analysis, or find a way to limit how many things they even can have. There's a situation in our domain where it's like, I'm not going to let you have, this isn't the domain, but I'm just going to say you can't have more than 1,000 items per order. Okay, that's enough for anybody, right? And then we'll know in the API that that's not going to be more than that, and we'll guess the limit. And then I guess the other option is just if you really don't have any idea, then maybe just don't let them get that association at that point. Does that, am I covering the bases, or are there kind of?
So as I've played around with complexity analysis more over the last couple of years, I've changed. Well, I didn't have. There were several ways to interpret, and you kind of got at this at the beginning of your question. How do you interpret the unit, so to speak, of complexity analysis? Are you talking about the load on the system? Are you talking about the size of the result payload? Like, what are we trying to characterize? And the principal thing that I have come to focus on is load on the system. So what we were trying to do, and by the way, complexity analysis is not there to stop adversarial users. Let me just start with that. It's designed to ensure that people who are trying to use the API in a largely okay way are not putting undue load on the system. And the reason that distinction is important is that if you think that the sheer act of analyzing a GraphQL query for complexity is too much work in a denial of service attack situation, right? Like that, there's the layer to handle denial of service attacks is above. It's at your load balancer. Ideally it should not be hitting your Elixir app at all. And this is not instead of stuff you might want to add at your Elixir level. Basic rate limiting by IP address. Basic, there are various measures you should probably take if you want to handle HTTP traffic, period. Then complexity analysis steps in to help, whether it's a developer in graphical who's trying to pull some data out of production, whether it's a partner who's going to be developing queries, it helps make sure that those queries do not put undue load on the system. Viewed in that way, then, the idea of multiplying subtrees by the number of requested records is actually not a good model for how load on the system works most of the time. It's because the load is not, generally speaking, in the JSONification of the data. It's in how many database queries do you need to make. So in your example, you talked about, I'm going to steal an example from my domain because then we don't have the user ambiguity confusion. Shipments, and you have questions like its origin location and its destination location, or shipment and events under them, right? I'm not going to, if I'm getting 10 shipments and then under that some things, I'm not going to do 10 database queries for each of their origin locations. I'm going to do one because I'm going to use data loader to batch that. And so we have largely stopped multiplying subtrees. Instead, the heuristic we sort of use is that if a regular field has a complexity of 1, a field that hits the database has a complexity of like 500. And you can think of it in terms of basically like microseconds. It's sort of hitting a database has 500 to 1,000 times more latency than X. I mean, it's actually even worse than that. But by the time you've spread out some fixed costs, we just actually have pretty. And then our total complexity limit is like really high. It's like 100,000 or something. And this like helps us model a little bit more of what we're actually concerned about in the system is basically total number of database queries. And if you're batching effectively, the total number of database queries is not linear with the number of some input limit is not really the case. Now, we then internally still make a distinction between associations that don't need to be paginated and things that do need to be paginated. If it's going to be basically like less than 100 records and we have some actual guarantee that it's going to be less than 100 records, then that field will remain there as just, you can fetch all of them. If it's going to be more than that, then we have to reevaluate its access patterns. And this is sort of complexity analysis aside. It's generally the case that if it's going to be 10,000 things, maybe we need to be reevaluating how we fetch it. GraphQL or regular GraphQL queries are not a great ETL mechanism. That's just not what they're built for. If you're trying to do very large bulk data fetching operations, either be happy with doing lots of little fetches or pick a different way of doing, like, please send me 70,000 things. Like, okay, or a million things. GraphQL is probably, JSON stops being eventually the way you want to do that either from just a efficiency perspective.
So if you're like Twitter and you're doing a GraphQL API, you do not want you page through the users and for each user give me all their tweets. Like, that would be insane.
Yes, that would be completely insane. Yes, yeah.
What you want to do is like, you can page through users and see their profiles maybe, but then if you want tweets for a given user, you need to page through tweets filtered by that user's ID. And then you can page as long as you need to, right?
Or even if you can fetch the tweets, it's that you're going to be getting, maybe you can get the most recent 10, like you can put pagination attributes in subfields. The mechanics but even then you don't need to necessarily multiply its value. So for example, if you are going to look at the front page of your feed, or if you're going to go to your friends list and it's, for whatever reason, it wants to show like the most recent tweet, you could have a dedicated most recent tweet thing if you wanted, or you could have a tweets subfield with a limit 1 that you put on it. Either way, you're still going to hit the database hopefully once. If you're Twitter, I don't know if you're going to hit a database, but that's neither. We can talk about caching in a moment. But yeah, that's the basic principle. Is big lists should be paginated. You can either do it at the top level or at an intermediate level, but you should always be enforcing sensible limits that reflect kind of what the underlying access pattern and load on your system is.
Okay, and another thing that I started down, I think, the wrong path on. I think it could make sense to say, like, you have a top level resource and then you have an association on that you can paginate, or you have a top level resource you can paginate and everything under it is flat. But it doesn't make any sense to try to paginate at 2 levels. Like, for every user, go through a page of users, and for each user go through a page of something else. Like, the cursors don't make any sense.
I agree that the cursors don't make any sense. And despite that, it is a surprisingly common pattern. It stops making sense the moment you're not on page 1. Page 1 actually does make sense. So if you think about a list of authors, and if you're going to list a bunch of authors and you were by each author going to show their most recent 3 books or something, that actually is perfectly cogent. It's just, if you wanted to then, to make up an overly complex UI, if each author row could like scroll sideways and you could look at all their other books, you wouldn't want to refetch everybody else's data anyway, right? So like there's that kind of interaction design, to your point, like maybe you can use that to fetch the initial data, but then any subsequent interactions are going to use a different access pattern. But even then, what's kind of neat is you could just get that one user, go to their books subfield, and so on, and then you're paginating at one level, but it's not the top level. So you don't necessarily need to be duplicating your paginations into the top level all the time just to make them cogent. But yes, it does not usually make a lot of sense. I've yet to see it make any sense where you have a paginated list of things under which for each item you're getting a paginated set of things and expect to query that again on page more than one. It doesn't make a whole lot of sense, but the page one scenario does. And thanks to a delightful contribution by somebody, I'm going to go look it up because it was such a fantastic contribution. Data Loader supports that. So it was actually a relatively lengthy affair to make all that work. First, Ecto had to improve how lateral joins worked so that it could do that sort of thing. And then somebody contributed that functionality to Data Loader, and I am very grateful for their work because my stance on it was that it's really up to there's no fundamental change in Data Loader that needed to happen. So if that was really important to somebody, then we were open to contributions, and they stepped up and did it. So that was great.
Cool. So another thing on the topic of complexity analysis, I think you mentioned one of the more difficult things about GraphQL as opposed to REST. One of the downsides is that rate limiting is not as straightforward, and so that's where complexity analysis can come in. And there's a post by Shopify where they describe doing something like this, where they say, we're going to give you a limit of X amount of complexity per minute or whatever. And they do that based on, I think first off, they analyze what is the complexity, the static analysis complexity. We're guessing how complex this is going to be up front. That's what we normally think of as complexity analysis. But then they have a second phase where they go, okay, how much work was that actually? And that's what we'll take off your tab. I don't know what kind of tooling they're using. As I was looking at the Absinthe docs, it wasn't clear to me how I could figure out the complexity, even at the static level, of a query that doesn't actually fail. Like if it fails, then the API is going to tell you, hey, this is what you're allowed to do. This is what you did. Sorry, try again. But if it succeeds, I'm not real clear on how I can get even what we thought it was, much less what it actually was. Do you have any tips on that?
Yeah. So this is an effort to make a one-sentence description of how Absinthe works. Absinthe has a pipeline of modules that each run in sequence and transform an input into something that's ready to run, runs it, and into a result shape. You can interject your own modules into that anywhere you like. And one of them is the complexity result phase, where it runs around and sums up the complexity that was done in the complexity analysis phase. So if you want to record what it is, whether it succeeds or fails, you can just interject your own phase right at that point and go look at it. It shoves that value somewhere. I don't know off the top of my head, but if you go look at the complexity result phase, I think, now that I think about it, I think the way it works is that there's the first phase does a walk down to, no, it does a post walk. So with trees, with lists are nice and easy. You can either walk them from the left or the right. Trees are a little bit more complicated. You're going to either like deal with each node as you walk down, or you're going to deal with them as you come back up from having walked down. Those are sort of your trade-offs. In Absinthe, we call that a pre-walk or a post-walk, pretty normal terminology. So we do a post-walk where you walk all the way to the bottom. You figure out what the weight of the complexity weight of each field is, and then you go up one layer and you sum your children, and that's the intermediate weight. And then you sum those children, sum. And so the complexity at the top is the sum of the whole tree. So and I'm 99% sure we put that value somewhere. It's probably on a field called complexity. I haven't looked at that part of the code in a little while, but if you look at it, that will tell you the complexity and you can register it somewhere. As far as the complexity of what actually occurred? That's actually a very interesting question. So and it's out to some degree outside the scope of Absinthe itself. Absinthe does not do any post-execution complexity analysis. You could because to some extent, this is squarely where, but it does give you the tools that you would need, I think, to pick one of the many strategies you might use to assess the complexity. So you could evaluate complexity as like how many database queries actually happened. And that is 100% opaque to Absinthe, because resolving a field calls a resolver function, and that is a black box as far as Absinthe is concerned. So telemetry is going to be your friend there. You could look at how many actual individual key value pairs are in the sort of result that you can get access to. You could interject a phase right after the final Absinthe phase where it builds a result, and you could just walk it and count the number of nodes. So you've got a couple of options there. I would, for me, my take is that if you're going to use it for rate limiting, I would use the pre-execution number, not the post-execution number, and then just try to make sure that you do some internal metrics of like, hey, we had this query that in the metrics. So apps with telemetry should be using metrics. Metrics are great. And so when you have requests that come in, if you're interested in complexity analysis and you're interested in making this like a really important part of how you handle end user interaction, you should be emitting a telemetry value from that phase that says, this is what we got. And then on that same request, of course, you have all of your ectotelemetry. And so in your metric analysis dashboard, Prometheus, Datadog, whatever you want to use, you could do things like, let's find queries where the complexity analysis number and the like total latency of the request, there was a big mismatch. Like, is this frequently happening? If so, which queries? Is it, on average a big mismatch and it's just completely mistuned? Or is it mostly fine and just sometimes it's not? And that, maybe we're missing an index in the database or whatever. So that's how I would do it. I'm sure Shopify, they do lots of great stuff. They have a lot of load. I think their situation is neat. It's not necessarily what I would do as a first pass. I would really only do that if I had a really strong sense of how each of these queries was going to execute, and I felt comfortable penalizing users for things maybe not going the way that you would expect. I think it would be strange, and I don't know their implementation at all, so all with a grain of salt, but I think it would be strange if I made a request and it failed because it was too complex, and then I made another request that was fine, but I made with slightly different argument values that didn't change numerically, but meant that the actual result was super different. Suddenly, like, I'm not able to make that request the same amount anymore. It becomes, I think, a little bit difficult to work in an expected way. I'll say this too, most of the time, the complexity analysis I view as more like guardrails on the road and less like they are there to help things from going egregiously wrong, and not so most queries should be most of the time well within those bounds. If most people are right up against those bounds, I think it's worth figuring out, like, what are my API users doing and such that we are barely letting them do what they want to do on our API. That would be an interesting situation to be in.
Yeah, that makes sense. Yeah, I think we're going to need to think through the complexity analysis a little bit more. It's something we grappled with a lot, and the actual complexity number that we set, the limit that we set, seemed insanely high, but it was based on some of those guessing high on associations and everything. So yeah, but I really like your point that it's not necessarily the payload size that you're concerned about, it's the number of database hits. So I think we can probably need to go back and rethink that. You mentioned adding something to your pipeline for something like capturing the analysis. We did attempt to do something with a pipeline at one point. Gustavo, you were, I think you were with me on that, and I'm trying to remember now. It was something to do with validation. Is that right?
Yeah, was to be sure that the query has some fields in it, like some
I remember now.
arguments.
Yeah. Okay, so for somebody who's asking for the first page of like a user connection right there, we want to make sure that they either provided us a first argument or a last argument, because otherwise we can't do our complexity analysis. And so we wanted to add a pipeline phase for that, and we kind of got stuck, like not being able to figure out how to do it. And we're like, oh, we'll do a workaround. We kind of found a different solution. But I guess we did see like Gustavo found an article where somebody was doing that for logging. I think they were logging complexity.
The complexity, yeah.
Yeah, but I just wondered if you had any good like pointers or resources on doing things with absence phases. Like any advice you have on adding our own phases to the pipeline. Where to start with that?
Yeah. So there's a couple of things that come to mind. One is I'll start by saying that I do think it's valuable to distinguish between, generally speaking, the validations that are part of the pipeline their job is to make sure that the request conforms with the schema, and GraphQL being introspectable means that this is a schema that end users can in fact ask. And in fact, there are, in programming languages with strong types, there's whole client frameworks that can introspect a schema, generate type information in that programming language, and then have really cool guarantees around whether your code will conform with the API. The validations that Absinthe performs in its pipeline are focused on that. And I definitely recognize that in the case of input arguments, sets of input arguments, sometimes we want to say either you have to provide this or you have to provide this. You can't not provide both. Right now, the GraphQL spec does not provide a way to say that in the schema itself. You can enforce that like a business logic, and there's in the same way that like there's no way in the type system to say you can't have numbers more than 500. You can totally do that in your resolver or in middleware, basically in the actual business logic part. You can put, and that's where all the usual stuff lives. Like this username is already taken, or it must be no longer than 37 characters. All that is business logic, basically, that you can totally do, but you wouldn't know just by introspecting the schema because it's not representable in the type system. So while I recognize, go ahead.
If I can just jump in there, that was the deal. Is like we were trying to make sure for the complexity analysis step that we had first or last, but that runs before the middleware. And so what we ended up doing as kind of a workaround was we have if you don't supply first or last, the complexity analysis is just like, we'll call it 0. And then, because it knows that the middleware step is going to say rejected, you have to give me one of these arguments. I think
that's valid. I don't think that's a hack. I think that's largely either it will run or it won't. Because remember, complexity is about load, and so it should actually, complexity is not some, I don't know, 100% a priori value that you can know just by looking at a schema. It is intrinsically linked to how the resolver works, because if it's an expensive resolver, it should be a highly complex number, and if it's a really simple resolver, it should be a low number. So those are inextricably linked. And so if you know that your resolver will pick a default, then your complexity analysis should just use that same default. If your resolver will fail to run and return an error because it's a mandated field, your complexity analysis can just assign it 0 because it's not going to run. I don't think that's a problem at all.
Okay, cool. But so for putting stuff in, for writing custom phases for the pipeline, like I said, we found one blog article that the author was doing this, but I think that was the only resource we could turn up that really sort of was of a tutorial nature. Is that because this is kind of new territory? Maybe it's not something a lot of people are doing, or is there something we're missing there?
No, that's a great question, and I know I don't know when your hard stop is, but because we're getting vaguely close to the end of time, I'll use that as sort of a jumping off point to answer your question and talk a little bit about things I've learned about sort of open source governance and what that means for Absinthe going forward. So, phases are not new. It's been how Absinthe has worked since 1.3, which came out. Um, let's find out. Packages Absinthe 1.3 came out in, thank you, hex.pm, 2017. So it's been a bit. And now, by the way, schemas use the same phase structure. So it used to be that the actual macros that you interact with in the DSL would also make the schema, and that's not true anymore. The macros make a blueprint structure, and then that blueprint structure goes to a bunch of phases, and that makes a schema. And so Absinthe has all these incredible capacities now for building schemas more dynamically, letting you hook into that to manipulate schemas in some way that you might choose. And it is all very not discoverable. When we were first writing Absinthe, we were focused on, I would say, two principal areas. The first was that it would work and be easy to use. We wanted something, and this fit the ethos of, I think, Elixir, the Elixir community. It's a lot of us are ex-Rubyists, and even those that aren't, there's this strong focus on building tools that are easy to use. We have slightly different, I think, a slightly different sense as a language community about what easy to use means. The Ruby community likes things that have as little code that you type as possible, and Elixir has, I think, viewed that as sort of the implicit explicit trade-off, that there's maybe too much. Sometimes the magic behind the scenes to make that work can actually make it harder to use. So regardless, strong ethos and easy to use, and that's what we focused on. And that you can see that in what we wrote documentation on. There's a book that takes you through how to use Absinthe. There's a bunch of blog posts that people have written. People have really engaged with that. It's worked really well. We put a lot of effort into making Absinthe able to be developed so that Bruce and I, and later Vince and I, could continue to develop it, adapt it to our needs within our companies. But both certain choices, like the choice of making the schemas macro based, meant that there was no good way to describe how it worked to people. It was the most complex use of macros, I think, in any code base, or certainly one of the most. It took me a week to remember to like get into the brain space every time I had to make changes to it. That didn't help. Even after we moved everything to a phase, we have not written a lot of literature on how to hack on Absinthe. And this was, I don't know if it's a mistake might be too strong of a term, because I think we made a lot of the best choices we could with the time we had. But the consequence of that is that there are people who have put in effort to understand how Absinthe works by poking around its tests, poking around, it just they needed to for their company, but it is not the most accessible. And this is a problem, because if an open source project or an open source language or whatever is going to persist, none of them ever do so because the original creator was just happy to keep spending 20 hours a week on it for 9 years. Like that rarely happens. Instead, it's much more that somebody or a small group of people put the effort to get something off the ground, and then they create something that can be extended, right? And Absinthe is extensible. It's very extensible, but you wouldn't know it, right? And there's no way to find out very easily. So I do hope that I have some time, when I have time to work on it. Actually, I'm trying to put more time into documenting this stuff. The reality is that, I've over the 8 years I've been at CargoSense, I've taken on more of a managerial role. I still write Elixir code all the time, but I definitely do not have time to be executing on some of the vision that I've had for Absinthe. And there's been some fantastic people who've stepped up to crack on it. But I think, and I've heard this echoed from Jose and Chris and others, where you make something that works for you and sets things in a good direction, and then there can be this very frustrating phenomenon that happens when companies, well-funded, startups or whatever else, get like on you about its performance or whatever. It's like, I did this for free. You have a developer budget of $50 million. Like, you can go make this fast if you want. And I think that can rub people the wrong way, but I think that is actually a critical part of open source being successful. It's like companies that stand to benefit from this, that have the budget to have team members work on it, like, should do so. And it helps if the authors are able to speak and write cogently about how their thing works so that other people can take it on. But, when I was first writing Absinthe, I was like, I remember being very almost like anxious about, oh no, like, is some company going to have this situation where it's not fast enough or it's not flexible enough or whatever. And as time's gone on, I'm like, they can hack on it. Like, so that's the beauty of open source. It doesn't bug me anymore. I love it for what it is, and also its worth at this point. And I think it's a great piece of. I've been very pleased with the response that it's garnered, and I don't mean no one should take this as not pointed at anybody in particular, but I think as the Elixir community grows up, I've seen this phenomenon happen in Phoenix. I've seen this phenomenon happen on the Elixir language itself, the Beam, where there's certain pressures get put on maintainers to do stuff like it's their job, and unless you're paying them, it's not. And so that has been really important for me mentally. Fortunately, with Absinthe, it's, I think, well suited to grow in this more mature way, but it could use a little bit of love on the docs about how it works. And so that's part of why I end up coming on these shows these days, is to just try to like put a little bit more of that information out there for people to know about, and hopefully that helps. That was a little bit of a tangent, but hopefully that gets at what you're asking.
Yeah, that's great. Well, I don't want to keep you all day. I know you've got plenty going on, but I really appreciate you taking the time to come on and chat with us. I have more questions I could ask you, but yeah, I think let's call it here. Thanks so much. This is Ben Wilson we've been talking with, and do you have anything you want to plug here at the end? Anything that
I'll mostly just say that the last year and a half has been really exciting for CargoSense. We've landed some really big customers. We're doing logistics visibility for Google data centers and some other really neat projects. We have hired a couple of Elixir developers this year. We expect to grow further next year. So we're not hiring this second, unfortunately. I wish I could be saying that right now, but if you're listening to this and you're interested in working at a company that's doing some really cool stuff with Elixir and IoT devices, and in the challenges of a physical process out in the world, keep an eye out. We'll be definitely looking to grow the team end of the year into next year. So
awesome. All right. Well, thanks so much, Ben, for coming on, and thanks everyone for watching and or listening to the show.
Great.
Ben.
Thanks for having me.
Thanks, man.